Four-sided figures are called quadrilaterals. And here we got a lot more variety and names to know. We'll start with the basic. If there is nothing regular or interesting or standardized about it at all, it is again called a scalene shape. Just means it's got some sides. No parallel sides, no congruent sides, no congruent angles, probably no right angles either. Let's increase the amount of order in our shape. Let's suppose we have a pair of parallel sides, exactly one pair of parallel sides. This shape is a trapezoid. You can think of it as a triangle that has had the tip cut off parallel to the base. So we could have carried on these two sides and we'd have a triangle, but we cut it off parallel to the base. That shape is a trapezoid. One pair of parallel sides. If the triangle that we cut the tip off was an isosceles triangle, then when we cut that tip off, the shape that we get left with is still a trapezoid, but it's now an isosceles trapezoid. It's got a pair of parallel sides, but the non-parallel sides will be congruent. And for that matter, it will have base angles that are also congruent. These two angles here, because it came from an isosceles triangle. And therefore, these two angles here will also be congruent. If instead of one pair of parallel sides, we have two pairs of parallel sides, then we have a situation like this. Remember, we can use multiple arrows. So the double arrow sides are parallel. The single arrow sides are also parallel. This is a parallelogram. Notice two L's first and one L at the end of it. Double L followed by a single L. Parallelogram. Two pairs of parallel sides. The opposite sides will also be congruent and parallel. Opposite angles will be congruent. So this one down here, this angle down here and this angle up here will be congruent, and the obtuse angle here and here will also be congruent. Properties of quadrilaterals will be explored later in the course. Again, at the moment, you just need to know their names and have some idea of what defines them as being those names. Well, let's not look at direction now. Let's look at length. If we've got two pairs of congruent sides, if we put those pairs next to each other, we get this shape. So this length and this length are the same, and this segment are also congruent. So what we have here is a kite. Two pairs of congruent sides that are adjacent. If we have two pairs of congruent sides that are not adjacent, so if they match and they're opposite, then we again have the parallelogram. Two pairs of congruent sides, and the opposite sides are parallel. If we make all four sides congruent, in other words, we take the two pairs of congruent sides and make them congruent to the other pair of congruent sides, then we end up with this, which is an amalgamation of a kite and a parallelogram. The adjacent sides are congruent and the opposite sides are congruent. It's a rhombus. And because it is both a kite and a parallelogram, it will have all the properties of both. This then is your equilateral quadrilateral. And instead of looking at lengths, we could look at angles. If we look for an equiangular quadrilateral, all the angles are the same size. That means they all have to be 90 degrees, and we have a rectangle. You could consider this to be a right parallelogram. It's a parallelogram where you've forced all the interior angles to be 90 degrees. So just like a parallelogram, it will have opposite sides being congruent and opposite sides being parallel for that matter. And then if we do the same to the rhombus that we just did to the parallelogram, we would have a square that is both a rectangle and a rhombus. It's in fact all of the previous shapes. It's a rectangle and a rhombus and a parallelogram and a kite because it follows all of those properties. It's equiangular, it's equilateral, so it has congruent edges adjacent, congruent edges opposite. It's equiangular and equilateral, and if you recall, that means that it is a regular quadrilateral, the only regular quadrilateral.